Let's talk about how to analyze simultaneous games. We'll start with a very simple case. We'll have two players. The best way to analyze simultaneous games is with tables. In our simple 2x2 example, the rows will represent all the strategies for one player, and the columns will represent all strategies for the other player. The cells contain payoffs for every strategy combination. By convention, the first number in the cell is the payoff for the row player, and the second number is the payoff to the column player. This table is formally called the normal form of the game. To identify Nash equilibria, circle the best outcome for row for every possible strategy that column might choose, and choose the best outcome for column for every possible strategy that row might choose. Find the cells where both outcomes are circled. The outcomes, or the cells, where both outcomes are circled is a Nash equilibrium. Let's do an example. Suppose that Time and Newsweek are deciding what to put on the cover of their next editions. This normal form here shows me that Time, who is the column player, has three possible choices. They can put Budget on the cover, Mideast on the cover, or Angelina on the cover. Newsweek also has the same three possible strategy choices. Newsweek is the row player. They can choose Budget, Mideast, or Angelina Jolie. The payoffs in these cells, or the cells, indicate the payoffs to both players. If Time chooses Budget and Newsweek chooses Mideast, the payoffs are 50-60. Newsweek will get a profit or payoff of 50, and Time will get a payoff of 60. Let's identify the Nash equilibrium. To do that, we're going to say, what's the best thing for Newsweek to do when Time chooses Budget, when Time chooses Mideast, and when Time chooses Angelina? And then we're going to flip the question around, what's the best for Time to do when Newsweek chooses Budget, Newsweek chooses Mideast, or Newsweek chooses Angelina Jolie? If Time chooses Budget, Newsweek will get either 90 or 50 or 20. Since 90 is the highest payoff in that first column, Newsweek would like to choose Angelina Jolie when Time chooses Budget. If Time chooses Mideast, Newsweek will get 50 or 40 or 80. Again, 80 is the highest payoff in the second column. So if Time chooses Mideast, Newsweek wants to choose Angelina Jolie. If Time chooses Angelina, again, Newsweek would like to choose Angelina Jolie because 50 is the highest payoff in the Angelina column. Now let's flip it around. What does Time want to do if what does Time want to do if Newsweek chooses Budget? Well, Newsweek Time can get 40 or 80 or 120. Time would rather get 120. If Newsweek chooses Budget, Time wants to choose Angelina because 120 is the highest payoff in that row. The highest payoff for Time in the Mideast row is 110. 110 is higher than 70, it's higher than 60. So if Newsweek chooses Mideast, Time would like to choose Mideast. Time would like to choose Angelina. And finally, what happens if Newsweek chooses Angelina? 90 is the highest payoff in the Angelina Jolie row. So if Newsweek chooses Angelina Jolie, Time would like to choose Angelina. The Nash equilibrium in this game occurs when the payoffs are 50 and 90. That's the only cell where both payoffs are highlighted. So the Nash equilibria is for Newsweek to choose Angelina Jolie and for Time to choose Angelina. The choices are not always symmetric in a Nash equilibrium. I've changed some of the payoffs around. Let's find the Nash equilibrium in this new game. If Time chooses Budget, The best thing for Newsweek to do is to choose Angelina, because 90 is the highest payoff in the budget column. If Time chooses Mideast, the best choice for Newsweek is budget, because 65 is the highest payoff in the Mideast column. And if Time chooses Angelina, the best choice for Newsweek is Angelina, because 50 is the highest payoff in the Angelina column. If Newsweek chooses budget, then Time would like to choose Mideast, because 85 is the highest payoff in the budget row. If Newsweek chooses Mideast, Time would like to choose Angelina, because 110 is the highest payoff in the Mideast row. And finally, if Newsweek chooses Angelina, Time would like to choose Mideast, because 110 is the highest payoff in the Angelina row. We look around, we see the only spot where we've got two payoffs highlighted is 65.85. The Nash equilibria is for Newsweek to choose budget and for Time to choose Mideast.